Getting a really clear, accurate picture of the human heart, it's one of the biggest challenges in modern medicine. It's this incredibly complex organ, and it's always moving. But now, imagine that a heart is tiny, and it's beating inside a restless little kid. Well, that challenge just becomes massive.
And that, right there, is the huge question we're digging into. This isn't just about some fancy new technology, it's about a much bigger idea. How do we get life-saving information in the kindest, gentlest, and most effective way we possibly can? Okay, let's get into it.
So to really get why this new innovation is such a big deal, we first need to understand the problem. And that means taking a hard look at what everyone calls the gold standard for checking out the heart.
So for years, doctors have basically had two choices. On one hand, you've got the cardiac MRI, or cMRI. It is unbelievably accurate. It's the best tool we have for measuring the heart's chambers. But it's super expensive, slow, and a really tough experience for the patient. Then, on the other hand, you have the good old 2D ultrasound. It's everywhere, it's easy to use, it's pretty cheap. The catch? The images can be kind of inconsistent, and you don't get all the data you need, especially for tricky parts of the heart, like the right ventricle.
And let's be real about what the MRI challenge means, especially for a kid. We're talking about a scan that can take up to 90 minutes. You have to lie perfectly, absolutely still, inside this super loud, really tight tube. For any child under 10, that's just not going to happen. And that's why they often need general anesthesia. It's stressful, it's expensive, and it's a huge logistical nightmare for the family and the hospital.
So, for what feels like forever, doctors have been stuck making this tough choice between getting the best picture and putting their patient through an ordeal. But what if they didn't have to choose anymore? A new innovation is trying to give them the best of both worlds.
Okay, so meet the VMS Plus system. It's this brilliant little device that just attaches to a regular ultrasound machine, one that you could find in almost any clinic. And its whole purpose is to take that easy, accessible ultrasound and use it to build an incredibly accurate 3D model of the heart with data that's as good as an MRI, and it does it in just a few minutes. Now, I know what you're thinking. That sounds almost too good to be true, right? How in the world do you get an MRI quality picture from a simple ultrasound scan? Well, the answer, as it so often is these days, is a really, really smart form of artificial intelligence.
The secret sauce is this technology called knowledge-based reconstruction, or KBR. And honestly, the best way to think about it is like a brilliant police sketch artist. The ultrasound gives the AI a few key details, like an eyewitness description of the heart. Then, the AI takes those clues and compares them to its massive library, its database of thousands and thousands of detailed heart MRIs it's already studied. And from just those few points, it builds a complete, accurate 3D portrait of that patient's unique heart. It's pretty amazing.
So here's how it all goes down, step by step. First, the sonographer just uses the ultrasound probe to grab a few key anatomical points from different angles. Pretty simple. Second, the KBS software instantly gets to work, comparing that info against its huge library of heart shapes. And finally, bam, it generates a full 3D model, giving doctors the precise measurements they need for all four chambers of the heart.
Okay, but the million-dollar question is, does it actually work? How does it really stack up against that gold standard MRI? Well, a clinical study put them head-to-head, comparing measurements of the right ventricle. And the results? As you can see, they were practically identical.
This number, this right here, really drives it home. The average difference between the VMS Plus results and the MRI results was less than 10%. Now, to put that in perspective for you, an MRI itself isn't perfect. It has an accepted margin of error of around 6%. So the VMS Plus is delivering data that's right in that same ballpark. That is clinically incredible.
So this amazing accuracy isn't just some number in a research paper. It has a huge impact on the critical decisions doctors have to make every single day. And to really see that in action, let's take a look at the work of Dr. Gregory Skinner and his team over in the UK.
Dr. Skinner's team sees a lot of patients with a condition called tetralogy of Fallot, or TOF. It's a complex heart defect that babies are born with. Now, they have an initial surgery when they're very young, but it's not a one-and-done fix. These kids need careful, constant monitoring for their entire lives.
And for a lot of these TOF patients, there's this huge looming question. When is the right moment to go in for a second major surgery to replace their pulmonary valve? If you do it too early, they'll probably outgrow the new valve and just need more surgeries later. But if you wait too long, their heart can become enlarged, causing permanent damage that even a new valve can't fix. It is an incredibly high-stakes balancing act.
The key to getting that timing just right? It all comes down to having super precise data on the heart size and how well it's working. Before, getting that data meant putting a kid through that whole MRI ordeal. But with the VMS Plus, Dr. Skinner's team can now get that crucial information easily and often, letting them track the heart's health over time and find that perfect golden window for surgery.
And you know, that brings us right back to where we started. Because beyond all the amazing data and the life-saving decisions, maybe the biggest impact of this technology is just on the experience for the patient.
Just remember that MRI ordeal for a second. We're talking about general anesthesia, separating a scared kid from their parents, and this long, loud, stressful procedure. It's just a truly awful experience for any family to go through.
Now look at the difference with the VMS Plus experience. It's night and day. A scan takes just a few extra minutes during a normal ultrasound. No sedation, no anesthesia. The child is awake, and most importantly, their parents can be right there in the room with them. It completely transforms a scary medical procedure into something that feels almost like a routine check.
And you don't have to take my word for it. Listen to what Dr. Skinner himself had to say about it. He said he was pleasantly surprised to be able to scan kids this young. The youngest he scanned so far is around 2 years old. I mean, think about that. Getting this kind of data from a toddler without putting them to sleep was basically impossible before. So, when you step back and look at the whole picture, it becomes so clear that this is much more than just a new machine. It's a fundamental shift. It's a move towards a smarter and, frankly, a much, much kinder way of taking care of people's hearts. The real magic word here is longitudinal monitoring. Instead of relying on one big, high-stakes MRI every year or two, doctors can now do several easy, low-stress scans. It's like watching a movie of the heart's health instead of just looking at a single snapshot. You can see the trends, track the small changes, and that gives you a much richer, more powerful understanding of what's really going on.
And this, right here, is the ultimate vote of confidence. Dr. Skinner says his team has so much faith in the VMS Plus data that they are now using it right alongside the MRI to make those huge, life-changing decisions about when to operate. That says everything.
And that kind of leaves us with this one last big idea to think about. For decades, the gold standard in medicine has always been about the machine, the most powerful, the most accurate piece of technology. But what if we've been thinking about it all wrong? What if the true gold standard isn't the machine at all, but the technology that gets us the answers we need with the kindest, safest, and best possible experience for the patient?